This video is about completing simple probability problems. So probability the chance an event will occur. Probability ranges from 0 to 1. So 1 means that it's always going to happen, and 0 means that it will never happen. A lot of the probability, though, is always going to fall between 0 and 1. So there are 3 steps to doing probability. First, you want to determine all of your possibilities. Then you want to circle your favorable outcomes, which we would call winners. And then to write our probability of the event, it's going to be the number of winners over our total possibilities. So first, let's look at some simple probability with just pulling one item. So in number 1, in a standard deck of cards, there are 52 cards. If you choose one at random, what's the probability that the card is red? So if we look at this card deck here, we have our 52 cards. Notice that there are 13 in this row and 13 in this row that are all red. So we would have 26 red cards out of 52, which reduces to 1/2. In our next one, what's the probability that it has a 5 on it? So if we look at our card deck, we have all of these are 5s. That is 4 of them. So we have 4 out of 52, which reduces to 1/13, which should make sense because each suit has 13 cards, and one of those would be a 5. In part C, has a face on it. So our face cards are our jacks, queens, and kings. There are 4 of each of them. So we have 12 total face cards out of 52. When we reduce that fraction, we get 3 out of 13. And then the last part is has an even number, and we are going to include our face cards. So we have 2, 4, 6, 8, 10. Our jack would be 11. Our queen would be 12. Our king would be 13. So we have 4, 8, 12, 16, 20, 24 of them are even cards. So we have 24 out of 52. And that is going to reduce to 6 out of 13. Number 2A. Given the words mathematics, if you choose one letter at random, what is the probability that you choose a vowel? So first of all, we need to figure out how many letters is in the word mathematics. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. And then we need to look at how many vowels this has. So it has an A, an E, another A, and an I. So that is 4 vowels out of 11. Now, even though A repeats, they're both a unique A in this case. Think about if I wrote them on like a a note card and I put them in a bag, right? I'd have to write A twice or I wouldn't have enough letters for the word mathematics. We're going to skip question B. In number 3, use the diagram to determine the probability of an event occurring. So find the probability that the point chosen at random is on angle C. So angle C is made up of these 2 rays. And on angle C, we have A, B, C, and D. So there are 4 possibilities out of 5 because E is not on that line. In part B, what is the probability that 2 points chosen at random lie on CA? Now, if we are choosing 2 points at random, it doesn't matter the order. So if I pick AB or BA, that's the same order. So we're not going to worry about the reverse. So when I write out my possibilities, I'm going to write out 2 letters at a time. So first I'm going to pair A with everything. So A, B, A, C, A, D, and A, E. Then when I move to B, I'm not going to worry about BA because like we said, order doesn't matter. So we just have BC, BD, and BE, CD, and CE, and DE because we're not worried about the reverses, okay? Which points lie on ray CA? So CA has 3 letters, A, B, and C. So any of those 2 as a combination would be a winner in this case. So we have A, B, AC, BC, and that's it. So we would have 3 out of 10. In part C, what is the probability that a point chosen at random and replaced and a second point chosen will both lie on CA? So this time, order does matter because we can pick the same thing twice. So additionally, we have to include our reverses of AB and BA. We also have to include doubles. So we could have AA, we could have BB, we could have CC because it's going back in to be a choice again on the second poll. So for A, we have AA, AB, AC, AD, and AE. BA, BB, BC, BD, and BE. CA, CB, CC, CD, and CE. DA, DB, DC, DD, and DE. And then we have EA, EB, EC, ED, and EE. So we're still looking for combinations that have an A, B, or C in them. So we have AA, AB, AC, BA, BB, BC, CA, CB, and CC. So in this case, we would have 9 possibilities that work out of a total possibilities of 25. So we have 9 25ths. In part D, what is the probability that 2 points chosen at random are collinear? So this would be a possibility of 1. Okay, and the reason why is because any 2 points form a line. In number 4, choosing 3 points at random, find the probability that the angle is named correctly. So first I want to find my possibility. So I could name it SAB, SBA, ABS, ASB, BSA, and BAS. So those are the 6 possibilities that I could rearrange those 3 letters. Now, if we have an angle like this, A is the vertex, so it must be in the middle of the name. So we have 2 possibilities that work out of the 6, which reduces to 1/3. In number 5, there are 6 angles here, A, B, C, D, E, and F. So what we're going to do here then is identify our angles before we look at our probability. So letter A is obtuse, letter B is obtuse, C is a right angle, D is a straight angle, E is acute, and F is acute. So we have 6 angles here. So in part A, if 2 angles are chosen at random, find the probability that both are acute. So if we're choosing 2 angles at random, it doesn't say anything about replacement. So we can't use double of the letters, and reverse doesn't matter. So when I write out my possibilities then, I have AB, AC, AD, AE, and AF. I have BC, BD, BE, and BF. CD, CE, CF, DE, DF, and EF. So these are going to be the possibilities that work for all of our questions for A, B, C, and D. So I'm going to pause this video to write those for the other 3 questions. So in part A, we want to find the probability that both are acute. So if we look back up here, our 2 acute angles are E and F. So they need to occur in the same grouping. So that only happens once. So we have 1 out of a possible 15. In part B, if 2 angles are chosen at random, find the probability that one is a straight angle. So one of them that's a straight angle is D. So anytime that we see an angle with D in it, that satisfies what we are looking for. So we have AD, BD, CD, DE, and DF. So that's 5 out of 15, which reduces to 1/3. In part C, if 2 angles are chosen at random, find the probability that at least one is obtuse. So if we go back and look at our angles, we know that A and B are the obtuse angles. So anytime we see an A or a B, we want to include that. or both is fine as well. So we end up getting 9 out of 15, which reduces to 3/5. And then our last one, what's the probability of one being acute and one being right? So our right angle is C and our acute angles are E and F. So we need C paired with E or C paired with F. So we get 2 out of 15. In part E and F, now we want to take an angle and replace it. So when we do that, we need to worry about order. We also need to include having double of the letters. So we would have AA, AB, AC, AD, AE, and AF, BA, BB, BC, BD, BE, and BF, CA, CB, CC, CD, CE, and CF, DA, DB, DC, DD, DE, DF, EA, EB, EC, ED, EE, EF. And then lastly, we have FA, FB, FC, FD, FE, and FF. In E, we're looking for if we have one angle chosen at random and replaced, and then choose a second angle that both of them are going to be acute. So remember that our acute angles are E and F. So we want any time that both E and F show up. So we have EE, EF, FE, and FF. So that is 4 out of 36, which reduces to 1/9. In our last problem, we have if we have one angle chosen at random and replaced, and the second angle chosen, that we're going to have just one obtuse angle. So if we're going to have one obtuse angle, we either have A or B, but we can't have both. So AC, AD, AE, and AF, BC, BD, BE, and BF, CA, DA, EA, and FA, and then we have CB, DB, EB, and FB. So that is 16 out of 36, which reduces to 4/9.